So we are solving some practice question under function. Practice question. These are wire question under our function. So the question is saying that two functions g and h, that means g is defined as, I say g of x is equals to 2 plus x, everything divided by x squared plus x minus 20, and h of x is x plus 3. The first question is now saying we should find g h of s. G h of s, that means it's a composite function in which h of s is serving as an input to g of s. In another, we write it in form of g h of x, and that gives us g into bracket h of x is x plus 3. H of s is x plus 3. That means anywhere I'm seeing x in g of x, I will be putting x plus 3. That's the meaning. Anywhere I'm seeing x in g of x, I will be putting x plus 3. Now, so now you can say that our g o h of x is now equals to, now we have 2 plus, now in g of x I have x, now I will put x plus 3 divided by, that will be x plus 3 all square, x plus 3 all square, x plus 3 all square plus x plus 3 minus 20. So if we simplify this further, this become x plus 5 at the numerator over, if we expand it, this become x squared plus 6x plus 9 plus x plus, that means plus 3 minus 20, that will give us 17 minus 17. And if we follow it through, that means we have x plus 5 divided by x squared plus 6x plus x, so plus 9 minus 17, that will give us, that will be minus 8. So we have x plus 5 over x squared plus 7x minus 8 minus 8. So that will be the function. And the second question there is saying the values of x for which g of x. Now, when this function now is undefined, so anytime you see the word undefined, it means we turn the denominator to 0. That means x squared plus 7x minus 8 is equal to 0. You see that denominator is a quadratic function. So we solve this quadratically now using the factor method. Now, that means that the factors we are going to use, we find two factors, we multiply to get minus 8, and we have to get 7. And that should be plus 8 minus 1 plus 8 minus 1. So x squared minus x plus 8x minus 8 equals 0. So if you now factor 8, so we have x in the bracket x minus 1 plus 8 in the bracket x minus 1 equals to 0. So the values for x there, that will be x minus 1, x plus 8 equals to 0. So that means my x will be 1 or minus 8. 1 or minus 8. The next part there is the partial fraction, and that one is not under the function of what we are dealing with. So we can move to the next question. Now, this next question is saying two functions f and g are defined as, now look at f of x there is x squared plus 2, and g of x is 1 over x plus 2. Here, x not equals to minus 2, because at x equals to minus 2, g of x will be undefined. Now, say find the domain of g of f inverse. So the first thing we need to do is to find g of s, to find the inverse before we now find the domain. So when we are saying g of x, that means we are saying g into brackets f of x. Now f of x is serve as input to g of x, and that's g into my f of x is x squared plus 2. So I'm putting f of x inside this. So anyway, I'm saying x in g of x, I will put in x squared plus 2. So that means g of means 1 over, now x, that's x squared plus 2 plus 2. That will give me 1 over x squared plus 4. So that's the composite function of g of x. Now I'm looking for the inverse. And don't forget, when we want to find our inverse, before say let y equals to 1 over x squared plus 4. Now, the second thing we do here is we swap x for y. And we are saying x is equals to 1 over y squared plus 4. So the next thing we do is to make our y subject of the formula. So that means if we cross multiply, then we have x into brackets y squared plus 4 is equals to 1. So that means y squared plus 4 is equals to 1 over x. When divide both sides by x, so y squared will be equals to 1 over x minus 4. So y will now be plus or minus root 1 over x minus 4. So that means if we factorize this, y will now be plus or minus root. That will be 1 minus 4x over x. So this is the inverse. So that means the inverse of that function now, we can represent it as another function. Since it's a composite function, we can represent it as another function. You can represent it as another function as maybe k. You can now say about the inverse of this now. I can say k inverse of x is plus or minus root 1 minus 4x over x. But don't forget, we are looking for the domain. The domain now. The domain is talking about the value for x. Don't let us forget. So what values of x will make this function to be true? What values of x will make this function to be true? To make this function to be true. If you see here now, since x is at the denominator, so x cannot be equal to 0. Because we make this thing undefined if you have 0 at the denominator. That's the first thing. X cannot be equal to 0. And you see here, if x is a positive number at this top, I mean this square root will be a negative root. And we cannot find the negative root on the real line. So that means that's moved to a complex plane. So we are dealing with real number. So x cannot be positive also here. If you check from that top, 1 minus 4x. So if x is a negative number here, if x is positive here, that means we have, for example, if you have x is 1, if x is 1 here, so this becomes minus 3. If x is 2, this becomes minus 7. You see the square root becomes the value of a negative value. So that means x cannot be 0 and x cannot be greater than 0. X cannot be greater than 0. So the only thing here, maybe our x can be less than 0. Maybe a negative or when we say x cannot be x greater than 0 here, x greater than 0, maybe that value of x will be a fraction. Maybe a fraction not up to 1. But now let's try to guess x cannot be 0. So if you say 1 minus 4x is equals to 0, so that means I'll say 1 equals to 4x. So x equals to 1 over 4. So at x equals to 1 over 4 here, so this becomes 0. So we can get it to be 0. So at x equals to 1 over 4, we can get it to be 0. But if you have less than 0, when x is less than 0 here, let's say minus 1, this becomes plus 4, this becomes 5. And you say x is minus 1 here, this is also square root. So what will be the range of value for x? So it has to be between 0 and this 1 over 4. 1 over 4 will be the highest value for x here, 1 over 4. So I think it will be 0 less than x, x less than or equals to 1 over 4. 0 less than x, x less than or equals to 1 over 4. 0 is less than x, that means x is greater than 0. And it will be less than or equals to 1 over 4. That will be our domain. The last question here, we are given that f of x is equals to x squared plus 1, and g of x is 5 minus 3x. Define a set of real number R. State the domain of f inverse, the inverse of f, and find g inverse of 2. Now we need to find the inverse of f. Don't forget, when you are looking for inverse, turn that into the y. That f of x, we say y equals x squared plus 1. So then here we make swap s for y. So x equals to y squared plus 1. Make our y solid of the formula, y squared equals to x minus 1. Y equals to plus or minus root x minus 1. So the inverse x, f of x, is plus or minus root x minus 1. So now to get the domain here, don't forget domain is the value for x. To make this thing true, to make this square root true, that means x has to be positive value. But x can be 1, so the square root will give us 0. If x is 2, we still have a positive. If x is 3, we still have a positive value. But if x is less than 0, it's not going to be true because we have a negative square root. So the domain here is x greater or equals to 1. If x is 1, 0 is 10. If x is 2, so that's the domain for our inverse of x. The second question says we should find, second question is saying we should find the g inverse of 2. That means we first need to find the g inverse, and we now put the value of x to be 2. So to get g inverse, we follow the same process. Say y equals to 5 minus 3x. Swap s for y, x equals to 5 minus 3y. make y subject to the formula. So we say 3y equals to 5 minus x, and y equals to 5 minus x over 3. So the G inverse will now become 5 minus x over 3. So G inverse of 2 now becomes, that means when x is 2, so that will be 5 minus 2 over 3, and that's 3 over 3, and that equals to 1. That will be equals to 1.